second video created by me. This one's going to be over our new TEK that we're studying this week. This is going to be 8.4c, and the TEK is use data from a table or graph to determine the rate of change or slope and y-intercept in mathematical and real-world problems. So just like I did with the last video, y'all, I'm going to go ahead and break down all the vocabulary terms in this TEK. This video is going to be the same thing as the first one. It will be done through Edpuzzle. There will be about 5 questions embedded into the video, and so you're going to watch the video and answer the questions, and then once you have done those, then you will be ready to move on to the next day. All right, so the first word we've got here is data. Now, data is a very loose word. Data is really just the information that we are using for the table and graphs. So this might be how many pairs of shoes does somebody have. This might be how tall somebody is, how much a plant grew, how good your ranking on Call of Duty is, how good your ranking is on 2K, how much weight you can lift. I mean, it can just go on and on and on and on. How many birds flew by your window. So data is just this very broad term that really means anything that you're going to build something off of. The second one's going to be our table. Now, oftentimes when we hear the word table, we think about where we're eating, what we're going to be sitting at to do our homework, maybe even where you're at right now working on this Jumpstart video. But a table in a mathematic term is really going to be something that looks like this. We're going to have our x values and our y values, and then we're going to fill the x and the y values with data points, however you want to say it. So this might be 2, 3, 4, 6, and 6, 9. And I'm just making those numbers up. I don't really have data to support those, but that's what a table is. You're going to see a lot of those in this TEK, and these tables are actually going to link up with our graphs, which is our next vocabulary word. Now, a graph is what we were talking about in the last video, and a graph is what we usually put our slopes or our lines on and we make pictures of. And so for this one, I'm actually going to use my table to create this graph. And so, for instance, I'm going to take, here's point 2, and then I'm going to go up to 3. And as you can see, this is going to continue going on much larger than I've really got it designed for, but it's going to create that nice line, which is going to have a slope, and that's what we're trying to accomplish with everything that we're doing today. Rate of change, that's a repeat word that we talked about last week when we did the video. Rate of change is just how often it occurs, how often the change happens, however you want to look at that. You know, is it happening every 1 second? Is it happening every hour? You know, how often do you have to get up and go to the bathroom? Is it continual or is it a more sporadic one? Slope, again, this is the one that has all the many words. It is the rise over run of our graph. It is also known as M, rate of change, unit rate, steepness, all those different things. It has that formula we talked about. So slope is really the focus of what we're looking at here. Y-intercepts. Y-intercept. This is called B. Don't ask me why. I'm not sure why we decided to put the letter B for y-intercept. But y-intercept is going to be the starting point of an or non-proportional line. Oftentimes, this is where we cross the y-axis. So if I go back to my graph here, my y-intercept is going to be this point right there. That's where I'm crossing, and that's where that would be. That'll come into play with our equations here shortly, and we'll go from there. I want to go ahead and reiterate this. You are still focusing on slope. That is the number one priority right now. We're trying to figure out what the slope of this line is. If anybody asks you on a question, hey, what is the purpose of this? You're looking for slope. That is the number one thing you are trying to accomplish. Okay, so I taught you a formula last week. That formula was M equals y2 minus y1 over x2 minus x1. Hopefully you're feeling pretty confident with that right now. If you are, then this lesson is going to be a breeze. If not, reach out to me. Let me know so we can spend some time practicing it and really get into to understand a little bit better. Oh, excuse me. All right. Now, from this, it doesn't matter which ones we choose. So I'm just going to call this my 1 column and this my 2 column. Okay, so x1, x2, y1, y2. So for my y2, I'm going to have 5 minus 2 over 2 minus 1. Well, 5 minus 2 is going to give me 3. 2 minus 1 is going to give me 1. 3 divided by 1 is going to equal 3. So that means that my slope, ladies and gentlemen, is going to go up 3 over 1. So if I start at this point right here, 0, 0, we're going to go up 1, 2, 3 over 1. Okay, now let's get a little bit bold here. Let's see what we've actually learned. It tells me that by going up 3 over 1, I should be at point 1, 2. Well, I'm off on that then. I've done something wrong here. Okay, another way that we could look at this problem is if I erase my 2 points here, that means that I didn't start at 0, 0. That means that I have to have a y-intercept. I don't have this super proportional relationship. I'll get into more detail on that on problem number 2. But what I want to do is I want to go ahead and mark the points that I have on here. So if we go to 1, 2, okay, well there's a point. And then we're going to go 2, 1, 2, 3, 4, 5. There's another point. Now let's test out our slope. 1, 2, 3 over 1. Okay, let's try this again. If I go up 3 from 5, I get to 8. And then 1 over from 2 is 3, so that one also works. We could also go down. 1, 2, 3 over 1. Okay, now this is where I want it to be. This, ladies and gentlemen, is what we call the y-intercept. It's called the y-intercept because this is where I'm crossing the y-axis. So if I drew my line, which we know goes on and on and on and on and on, I'm not crossing at the origin. I'm starting at -1 instead. That's not a big deal. It's okay. It's just part of the problem. So like I said, I started at 0. It didn't work out. It didn't give me the numbers from my table. Now my table and my graph have to be the exact same thing. I can't have one without the other because the table is the data, and the data is what we put on the graph. So now if I want to write this equation out, this equation is going to be in the form of y equals mx plus b. We call that slope-intercept form. Now just bear with me. I know you got 4 letters and you're thinking, why in the world are we mixing 4 letters into a math problem? I know. I don't have a good answer. Blame the math gods. It is what it is. Okay? So what we want to do now, though, is we're going to just kind of play with this problem for a second. The x's and the y's are the same x's and y's from my table, the same x's and y's from my graph. The slope is going to be 3. The slope is because my formula m is equal to this. We worked it all out, so m is going to be equal to 3. And I just told you a few minutes ago that we're going to use this point, my y-intercept, where I cross the y-axis, and that number is a -1. So if I write this problem out, y equals 3, x minus 1, I've now written this problem in slope-intercept form. I'm going to let that digest for just a second. Because I've now proven to you that the table and the graph match. Now I want to prove to you that the equation also matches this. So prepare to have your mind blown. Okay, I'm going to just pick this last point right here. Just randomly choosing this last point, okay? And I'm going to take those numbers and I'm going to plug them in. So my y value is 11. So I'm going to have, let's do it up here, give us a little more space. So we're going to have 11 is equal to 3, because 3 is my slope. Well, if y is 11, then x has to be 4 minus 1. 11 is equal to 12 minus 1. 11 is equal to 11. So that proves to me that that formula that we created right here, based off my slope, which we found over here, and my y-intercept, which we found on the graph, plugged in, produces the same results over there. Pretty cool, huh? All right, let's go and look at number 2. All right, now number 2, I gave you a little bit different of a response. This one might be a little bit easier for some of you. It might be a little bit more challenging for others. But what number 2 does is it proves to me that I already know I'm not going to go through the origin, that I already have a different spot, because if my x is 0 and my y is -1, then I have to start at this point right here. Another point I can choose is -1, -3. Another one we can choose is 1, 1. Another one we can choose is 2, 1, 2, 3. And the final one we can choose is 3, 1, 2, 3, 4, 5. Now, once again, ladies and gentlemen, this is coming from the data that's given to us. This is a mathematical problem, not a real-world problem, because we don't know what it's referring to. If it was real world, it would have some sort of connection to it, like we'll see on problem number 3. Okay, so I've got my graph done. I'm going to go ahead and draw this line through here. Okay, there's my graph. Table, graph. We could find the slope using a number of different ways. We could use the slope formula that we used over here, or we could use the rise over run method. Rise over run is that same thing that we use with our triangles. So see, I'm trying to connect everything together. So I'm gonna go from this point, I'm gonna go up 1, 2, over 1, 1, 2, over 1, 1, 2, over 1, which means that I'm rising 2, running 1, and if we simplify that, then we know that our slope is now going to be 2. Okay? Data from a table creates the graph. Graph helped us find the slope. So I did it the exact opposite of example 1, but I'm still proving all of the same ideas. I'll take it a step further. That formula that I taught you, slope-intercept form, y equals m times x plus b. Okay, what do we know from this problem so far? We know we've got tons of y's and tons of x's, but we're gonna leave those blank. My m, or my slope, is going to be 2, x minus 1. I know that our y-intercepts both ended up being -1. That's just a coincidence. It's not always going to be -1. It could be positive numbers. It could be negative numbers. This is just what we have right now. So I want to actually show you two things here. I'm going to choose this one right here this time. I'm going to choose the 2, 3. Just totally random. So I'm going to have 3 is equal to 2 times 2 minus 1. Well, according to order of operations, we multiply first. Minus 1, 3 equals 3. That checks out. Okay, now this is the part that all of this really gets the most interesting. Let's say that I continue. I'm going to put some ellipses here. I continue this table out, and I end up and I say, okay, I want to know what is the y value if x is 41. So if x is 41, what is this random y value? And so what I'm going to do is I'm going to take the same formula, y equals mx plus b. I don't know what my y is, so my y is going to stay a variable. I know that my x is my slope, or my rise over run, so that's going to be 2. My x is 41. And I know that my b is -1. And so now what I'm going to do is I'm going to solve this out. We're going to have y is equal to 2 times 41, which is 82, minus 1, y is equal to 81. So what that means is that because I knew what my x value was, I was able to determine my y value based off the slope-intercept formula. So it's a lot going on, you guys. I'm just trying to convince you of two things. Number one, how do you find slope? And number two, what can slope do in all the different forms? All right, let's talk about a real-world problem real quick. I don't know how many of you guys are into Pokemon. I'm not as into Pokemon as I used to be. But as a kid, I loved it, and so it's always fun to kind of rehash my nostalgia or my fun facts from being a kid. All right, so it says, your sister gives you 30 Pokemon cards. Your uncle tells you that if you pick up the dog poop every month, he will buy you 10 more Pokemon cards every month. How many cards do you have after 1 year? Okay, so let's just break down this idea. How many cards are you starting with? You're starting with 30, okay? And then it tells you that if you pick up the cards, you will get 10 every single month. So that's 10. Now we're going to use a variable to represent an unknown number. And that variable is going to represent the number of months. If we get 1 month, then we get 10 cards. If we do this for 2 months, then we get 20 cards. If we do this for 3 months, we get 30, so on and so forth. Now the question says, how many cards do you have after 1 year? Well, let's see. How many months are in 1 year? January, February, March, April, May, June, July, August, September, October, November, December. There's 12. So that means that what we want to do is we want to multiply this x value as 12 because that's how many months we're going to be doing this problem. So let me write this formula out. Again, it's going to be y equals mx plus b. We don't know what our y is. That's our total, so we're looking for. We know that the slope is going to be 10 because we are getting 10 cards per month. That is my constant. That's my rate of change. I am changing by 10 every single month. So January, I get 10. February, I get 10. March, I get 10. So on and so forth. We've already established that there are 12 months in a year. So at the end of a year, I will have gotten 10 times 12 because it's 12 months per year. But here is what gets really interesting. I've got to add the y-intercept. Remember, the y-intercept is our starting point. We already have 30 Pokemon cards from your sister. So what ends up happening is you have to add those 30 cards to the cards that you're going to acquire throughout this process. So y equals 10 times 12, which is 120, plus 30. So y equals 150. So at the end of 1 year, you will have 150 Pokemon.